Hey everybody. For this lesson today, we're going to focus in not on number theory as a whole, but a particular theorem that we've talked about a lot this semester in just little bits here and there. But we're going to talk about Fermat's last theorem, or Fermat, I believe is how we actually should be saying his name. So his theorem is one that we've talked about, and it's kind of the next step from Pythagorean's theorem, where Pythagorean's theorem said a squared plus b squared equals c squared. Fermat started saying, well, what if the exponents were 3s or 4s or 5s? Would the relationship hold true then? And he said, no, it would not hold true for any number above 2. And he was working through Diophantus's book when he wrote in the margins that there doesn't exist any number where this happens. And he said, to divide a cube into cubes, a fourth power or general power, whatever, into two powers of the same denomination above the second is impossible, and I have assuredly found an admirable proof of this, but the margin is too narrow to contain it. So this notion that I found a proof, but I can't write it here because there's not enough room, has spurred people on for years. His son actually found the book, the Diophantus's book that he had been working in after he had died. And there were things written all over the book. And he republished the book with all of his father's notes published within. And from there it was picked up by others over the years. So, most importantly, I'd say in this particular book from Diophantus with Fermat's notes in it, every place he noted that there was a theorem, but he didn't include it, Euler came by afterwards and was able to prove everything else that was there. If he said there were proof existed, he proved it. This was the one that nobody was able to prove for a very, very long time. So some things that kind of happened over the years. We have Fibonacci, who well before Fermat had been considered the same thing. In 1225, he proved it was not possible for the special case of n equals 4. Sophie Germain, who we're going to talk about in a couple of weeks, one of our famous female mathematicians in 1815, around there, did a proof for all primes less than 100, saying for all primes less than 100, with the exception of 2, nothing else would work. Ernest Kumar, in the mid-19th century, proved it for all regular prime powers of n. Gerhard Frey, he suggested how to go about proving the theorem, but two other proofs were needed first. One was the epsilon conjecture, and the other was and I'm going to say it wrong, Taniyama-Shihirama conjecture. The first one was proven in 1986 by Ken Ribet. And Andrew Wiles is who I've mentioned to you before, who actually is the one who proved Fermat's last theorem. Somebody suggested that this other proof, the Taniyama-Shimura conjecture, that was the key. So he set about working on that, because once you got that, it was conjectured that you'd be able, Fermat's last theorem was a piece of cake from that. So he started working on that. Excuse me. In 1993, he actually was able to prove that. And then he worked on, went from there to the general proof. He worked in secrecy for 6 to 7 years, and he presented his solution in the summer of 1993 at a series of lectures in London. And I think I told you the story of myself that summer sitting in a math lecture at Rice University and somebody running through the back to tell us that Andrew Wiles had proven Fermat's last theorem. However, as with any proof, especially of this kind, people check to make sure you haven't made a mistake, and there was an error that was found. He went back to work on this, worked for over a year to make a correction, and finally published what has been accepted as a correct proof in 1995. So, Fermat's last theorem, it wasn't proven until 358 years after it was conjectured. And that's what we're going to look at a little bit during this particular module. You're going to go through, you're going to hear from Andrew Wiles himself. You're going to hear from the number file guys as they kind of tell you a little bit more about the history of this and its importance, and we'll even look at it in modern culture. At the end of this, you'll be asked to write a reflection, so do take notes as you're moving along so you're ready for that. Take care, and I'll see you next week.